I believe we started looking at this problem here. We did say, I think, determine that it was a minimum. It would have a minimum value, but that was about it. Yes? So, now, yesterday we did have the graphing calculator pulled up, and we could type the function in. Now, the first thing we would hit would be y equals. Now, because it starts off with 1/2, we can go alpha y equals enter 1/2 x squared. I'll take them. That way I can figure out what's what. Then we have minus 2x minus 1 was our function. Was everybody able to get it typed in? Yes? And once we get it typed in, what do we do next? Well, I would hit graph because we can graph it and then we can do the trace to calculate the minimum value. Because yesterday we did hit graph first to see that this is opening up, so it does have a minimum value. It will not have a maximum value. Was everybody able to get the graph? What's up? It's cleared. There's nothing there. You're typing that in. Alpha y equals enter 1 down 2 over. Does anybody else have any other issues with typing this in? Were we able to get this typed in? Yes? So once we got the function typed in, we want to find the minimum value. To do that, we can do second trace, and we can go down to number 3, which is the minimum, yes? Now, what number is next to minimum? 3? If you hit 3, it'll actually pull the minimum up. Now, the first thing it asks is for the left bound. We need our little marker to be to the left of the minimum value. Well, is it to the left of it already? Yeah, so we can go on and just hit enter. Now it's asking for right bound, so we need that little blinking X to be to the right of whatever the minimum value is. So we can use the right arrow to move it over. It really doesn't matter how far to the right that we have it, as long as it is to the right of it. It's past that point. And once you get that, we can go on and hit enter. Now at this point, you should have 2 arrows facing each other, and the minimum value should be between them. So the minimum value is between those 2? Well, yes, the lowest point. Now at this point here, it's wanting you to guess. If you wanted to give a guess at what you thought it could be, you could put it in. But we just go on and hit enter. So this minimum point is also going to be the vertex. So the vertex for this equation is going to be at the point what? What do y'all think? So this is right there. 2, -3. Now the point 0.0000016 is really just a pixel error, because again, it's using the actual graph in the pixels. So sometimes this can be just a little bit off, but the vertex is the point 2 comma negative 3. But it also means that the minimum value is at negative 3. Because when we talk about maximum or minimum values, we're talking about the y values. So I'll pull the note sheets back up. So our minimum value is negative 3. Now we already said the vertex is the point 2 comma negative 3. What would the domain of this function be? Anybody know what the domain would be? What would the domain be? Because when did I say the domain wouldn't be all real numbers? Because I talked about the domain being all real numbers yesterday. But would it be anything dealing with quadratics? Well, no, because I mentioned what? Rational functions and radical functions. So when we looked at this yesterday, I highlighted both of these because the domain was all real numbers. For any polynomial function, the domain is going to be all real numbers. Now the range, again, we're talking about the y values. Well, if I look at this here, what is the smallest y value? Negative 3, and they're all what? Greater than it, yes? So if we talk about the range, well, we're talking about what? All the y values that are what? Greater than or equal to negative 3, because if we look at that graph, well, the lowest point that it can be is at negative 3. That's all the values that are bigger than it. Any questions on any of this here so far? Well, the only thing we have left is increasing and decreasing. So it's going to be easier to see this if we look at the graph itself. Now, we read a graph from left to right. We always start on the left and come to the right. So if I'm reading this graph coming from the left side, what is happening to the graph? It's going down, yes? So it is decreasing. Now, where does it stop decreasing at? At the y value of negative 3, but what is the x? 2. So really, as we're coming this way along the x-axis, the entire function is decreasing until we hit 2. And what happens after 2? It starts increasing. Now, the textbook, how they're going to look at it, they're going to say this function decreases to the left of 2 and increases to the right. Because at 2, it does what? It turns, doesn't it? They actually call this a turning point because it goes from increasing to decreasing or decreasing to increasing, because if it makes that switch, it is considered a turning point. Now, the way that I think is better to look at this, so we can say decreasing, because it's always increasing and decreasing is according to the x-axis, the x values. So it's decreasing, well, it starts way off on the left side, yes? Well, we can go as far out and it's still going to be coming down as we read from left to right. So the smallest value we could have is actually negative infinity. Where does it stop decreasing at? 2. Because from negative infinity to 2, because we start way off on the left, You'd have to increase the size of the graph or the picture very big to see it, but it is decreasing. It's coming down all the way to 2. And at point 2, well, is where it starts increasing, yes? And where does it stop increasing? Does it? No, so it'd be 2 to infinity. I want to write it in this way because if you end up having to take a math class in college and they ask about decreasing and increasing, they're not going to say, most likely, oh, it's decreasing to the left of this point and increasing to the right of this point. No, they're going to want it in interval notation. Because we can also have graphs that increase for a certain range, then decrease, then increase, and then decrease. Because we can have it going up and down. So we can have multiple ranges where it increases and decreases. So just saying to the left and right really doesn't help us. Interval notation is better. But that's it. That's all this is asking for. Questions on this here? Okay. Let's look at the next one. Which one do y'all want to look at, A or B? Which function do y'all want to look at? Okay. F of x equals 4x squared plus 16x minus 3. Well, let's just go on and look at let's plug it into the calculator and let it do it for us. So where do we go first? We go to y equals, yes? Do we want any of that function at all? No, so I can clear it. I can clear it out. Now we can type in 4x squared plus 16x minus 3. And once you get that typed in, we can go on and just hit graph so we can kind of see what the function looks like. And we get something like this here. Now, will this one have a maximum or minimum value? It's going to have a minimum because it's opening up, yes? So it's going to have a minimum value, but it's somewhere way down below the graph. So we'll have a minimum value, and we're going to find out what it is. Well, to calculate that, we can do what? Second, trace, minimum, so we can hit the number 3. So we do have our blinking X, and it wants the left bound, yes? Are we to the left of the minimum value? No, because the minimum value is to the left of it. So we can go over to the left. Really, at this point, we could be good. Any of those there would work. And once we get it to the left of the minimum value, we can hit enter. Now we need it to the right of the lowest value, yes? Well, here y is negative 8.28, negative 10, negative 11, negative 13, negative 14, negative 15, 16, 17, 18, 18, 9. Well, wait a minute. Did the y value just go back up a little bit? Yeah. 18, 5, 18, 17. So really at this here, I passed the minimum point because the values are going back up. So I could hit enter at this point here because I don't have to wait for it to come back up into the screen. But once I notice that it's stopped, it's actually past that point, we can go on and hit enter. So we have the minimum is at negative 1.9999999. Well, what is the x value at the minimum? Did you get? Yeah. Did anybody else get negative 2 point, a whole bunch of zeros, and then I think a 2? Yes? Well, these are the same thing, aren't they? Because it just depended on where you put your right bound or left bound. Put both of those there. But really, this is negative 2. If we'd have done negative b over 2a, we would have gotten negative 2. Because it would have been negative 16 over 2 times 4. Well, that would have been negative 16 over 8. Negative 16 over 8 is negative 2. Because again, because of the pixels amount, it can differ very slightly. But again, the minimum value is not so much focused on the x, it is on the y value. So our minimum value is 19. So the minimum value is what? Negative 19. What is the domain of this function? All real numbers. What is our range? Y is what? Or equal to negative 19. Because again, if it opens up, we're talking about greater than or equal to. If it opens down, we're going to talk about less than or equal to. Just what are the y values that are being covered? Is it all the points that are bigger than negative 19? Or is it all the points that are less than negative 19? What y values are being covered? And the last part is our increasing and decreasing. Right here. So coming from the left on the x-axis, so until we hit negative 2, is the function increasing or decreasing? Decreasing is going down, yes? So we can say from negative infinity to negative 2, it is decreasing. From negative 2 to infinity, it is increasing because it's going back up. So we can say is it is increasing from negative 2 to infinity, and from negative infinity to negative 2, it is decreasing. And that is it. Questions on this here? Okay. No questions on that there. Let's go and look at the next page. Now this is the last one that we're going to look at. F of x equals a times x minus p times x minus q. This is the intercept form of the equation. And the reason we call it the intercept form is because f of p and f of q both give us 0 for the function. It's where it crosses the x-axis. So p and q are the x-intercepts of the graph of this function here. Now the axis of symmetry is going to be halfway between these 2 points, these 2 intercepts. So really, if we want to find the axis of symmetry, x is going to equal p plus q divided by 2. And the vertex is going to be p plus q divided by 2, comma, f of p plus q divided by 2. And the x-intercepts are just going to be p, comma, 0 and q, comma, 0. P comma 0 and Q comma 0. Any questions on this here so far? Let's look at the x-intercepts first. So the x-intercepts for this are going to be the point P comma 0 and Q comma 0, because the x-intercepts are the point where it crosses the x-axis. And the value of y at the x-axis will always be 0. So what is the value of P and Q? Because it would be in these places here, yes? Where 3 and 1 are at. But in the equation, what do we have? We have x minus P and x minus Q, yes? So if it's x minus P and we have x plus 3, the value of P is not just 3, but it is negative 3. And when we have x minus 1, the value of Q is positive 1. So again, with these parentheses, the values that come out are going to be the opposite of what we think, because it's plus 3 inside the parentheses. Really what we're saying is that we actually have x minus negative 3. And this here is just x minus 1. Because according to the formula, it is a times x minus p times x minus q. So we get negative 3 and 1. So p is negative 3 and q is just 1. Now the vertex is our p plus q divided by 2, comma, f of p plus q divided by 2. And our axis of symmetry is x is equal to p plus q divided by 2. Well, the first thing we need to do to solve this is just take p plus q and divide it by 2. Well, what are our p and q values? Negative 3 and 1, yes? So the first thing really we can do is negative 3 plus 1. Ooh, I need to move that. Is negative 2 divided by 2. And negative 2 divided by 2 is negative 1. So the axis of symmetry would be x is equal to negative 1. And the x value of the vertex would be negative 1. Any questions on this here? Now what would be the y value of the vertex? And what do we need to do to find it? So we can take the original function and plug back in negative 1 for all the places where x is. So we can take the function negative 2 parentheses. It would be negative 1 plus 3, close parentheses, open parentheses, negative 1 minus 1. We're really just plugging it back into the function. Just like we did with standard form, we're doing the same thing here. Negative 2, parentheses. Well, negative 1 plus 3 is 2. Negative 1 minus 1 is negative 2. Well, negative 2 times 2 is negative 4. Negative 4 times negative 2 is Just 8, positive 8. And that's it. That's all it's asking for. Any questions on this here? Any questions on any of this here? Are we good with this here? Yes? Okay. Let's look at this one here. So we're not worried about graphing it, but we want to find the X-intercepts, the vertex, and the axis of symmetry, yes? Let's use the graphing calculator to find this. None of this was here. So the first thing we need to do to graph this is going to be to hit y equals. Now we'll clear that out so we can type the new function in. Well, the first thing we have is negative 1/3. So we can say negative alpha y equals enter to bring up the fraction. We can say 1 down 3 over parentheses x minus 4 close parentheses open parentheses x plus 2 close parentheses. And we have the whole function typed in. Any questions on this here? Now we can go on and graph it to see what the graph looks like. And we have this here. Now it kind of gives us the x-intercepts, the places where it crosses the x-axis. Yep. Because it looks like we do have 2 places where it crosses, these 2 here. Now we can go second graph and look at the table. Negative 2, 0 is one of them because it is an x-intercept when it crosses the x-axis. It is an x-intercept when it crosses the x-axis. So negative 2, 0 would be an x-intercept. Now we can scroll down. And the other x-intercept is at 4, 0. So we got one of the 3 that we need. We got the x-intercepts, and we know that they're going to be the x-intercepts because the y value will be 0. The y value has to be 0. Now we just need to find the vertex and the axis of symmetry. Now we know the vertex, the x value of the vertex will be exactly between these 2 points. Well, what number is exactly between them? 1, so 1, 3. Now another way we can get it is by doing our second trace and our minimum or maximum for this one. It would be a maximum, because if we notice here the graph is going down, so we will have a maximum value, because there will be a highest point for this graph. Now we are already to the left of it, so we can go on and hit enter. If we want to go over, to the right of it, hit enter, and enter, it tells us that the vertex is at what? 1, 3. So our vertex is at 1, 3. And we were able to see that on the graph. Which also means our axis of symmetry is x is equal to 1. And that is it. Now, if we wanted to actually calculate it, we could say P plus Q divided by 2. Well, our P and Q are 4 and negative 2. So we can add these two together. 4 plus negative 2 would be 2, and 2 divided by 2 would be our 1. We would get it either way. So there's more than one ways to get to these points. Are there any questions on any of this here? Do we need to see another example of one of these? Do we feel comfortable with these here? Okay. That is it for today.